Assalamualaikum and hello to our beloved lecturer. Okay, so today I would like to introduce myself first and my team members. Firstly, me, Muhammad Lukman Hakim bin Muhammad Azhar, PC 18030, and second, Muhammad Yusuf bin Patahuddin, PC 18078, and third, Muhammad Zuriza bin Zulkifli, PC 18046, and lastly, Muhammad Nur Akmal bin Muhammad Noor Azmi, PC 18098.
Let me introduce myself first. And my name is Muhammad Yusuf bin Patahuddin, PC 18078. Let me preview our case study in the assignment 2. So let's see our case study.
Okay, the question 1 is show, find and create a case study related to the analysis of variance Anova. State the objective of the study and why is it related to Anova. So, our group on the case study
is a clinical trial is run to compare weight loss program, and participants are randomly assigned to one of the comparison program and are consulted on the details of the assigned program. Participants follow the assigned program for 8 weeks. The outcome of interest is weight loss, defined as the difference in weight measure at the start of the study baseline and weight measure at the end of the study 8 weeks measure in pound. 3 popular weight loss programs are considered, which there are statistically significant difference in the mean weight loss among the 3 diets. Use alpha 0.05.
So this is the data of the weight loss program: low calorie, low fat, low carbohydrate. So the objective is first to determine if there are statistically significant difference in the mean weight loss among the 3 diets. Second, to understand and know how to calculate Anova by manual by using Microsoft Excel, and why this is related to Anova. So to know why this is related to Anova, first, this data using more than 2 means, which is 3 means of the data. And second, the case study is one-way Anova. And next, the case study involves one factor. And the last, do not have an interaction effect of factor. So to answer the question 2, the question 2 is construct an Anova table by using Microsoft Excel. Correctly key in all the data and display the output. This is the data. For the group, low calorie count is 5, low fat is 5, carbohydrate is 5, is the count. The sum, which is a sum, average, and variance, we can get by using the calculator. Before this, we have learned from the class. So this is the data from the Microsoft Excel. Let me show you the Microsoft Excel. So let me show you how to get the data from the summary. So this is the data count 5, 1, 2, 3, 4, 5. So we can put from to the count 5, 5, 5 actually is the same. So to get the sum, which is we can sum all about the low calorie, which is get 33, and the means average, which is we can get from 33 divided by 5, we can get 6.6, and the variance we can use the calculator to find it, and the next low fat, which is the same step, we can get from this data, we can get 50, and divide by 5 we can get 3, and low carbohydrate same also, we can get 70, divide by 5 we can get, means our average is 3.4. And next step is which is we can put in our calculator. Actually, this data is we can put our calculator. We can find this. So this is the summary. So to get Anova, we use this data and click the Microsoft Excel. We put in the Microsoft Excel. We can get this SS, which is the standard. We can get 3.3, which is a 2. The data we can use, this is p-value, SS, DF, MS, to the next step of the question. So that's all from me. The next question our group will present. Thank you.
Assalamualaikum and hello. My name is Muhammad Luqman Hakim bin Muhammad Azhar, PC18030. Okay, first of all, Yusuf, from the case study, how we want to know whether the case study is one-way ANOVA or two-way ANOVA, and what is treatment? Can you explain it to us?
Okay, Lukman, to answer your question, let me show you the question first. One way or two-way ANOVA. To know the data is one way or two-way ANOVA, this data is one-way ANOVA because it's only use one factor and do not have interaction effect of factor. To know how many treatment in the factor, which is have a 3. So this is a 3 treatment, which is a low calorie, low fat, and low carbohydrate. So Lukman, how about the total number of replication and which value represent SS, TR, SSE, MS, TR, and MSE? Can you explain for us?
Okay, thank you Yusuf for the question. Okay, now I will answer the question on what is the total number of replication and what value represent the SSTR, SSE, MSTR and MSE. So let's go. Okay, now let's we take a look on how to find the replication. So first let we see the case study. Okay, from the case study, we know the observation is 5. So the observation is represent the total number of replication. So the total number of replication is 5. Okay, now let we answer the second question for Yusuf. So the second question is which value represent SSTR, SSE, MSTR and MSE. So now let's take a look on the ANOVA table. So from the ANOVA table, we know the SSTR and SSE, MSTR and MSE. So the SSTR is the sum or square of treatment. Treatment is a between group, and SSE is a sum or square of error, that is a within group, and MSTR is a mean square of treatment, and MSE is a mean square of error, that is a within group. Okay, so the value represent the sum of square treatment is 38.933. The value represent the sum of square error is 36.4. For the mean square of treatment is 19.467, and mean square of error represent the value 3.0333. So the value is represent for the all of the sum of square and means of square.
Okay, that's all for me. I hope that you all can understand on what I explained before this, and I hope that you all can do the Anova by yourself after this. Thank you.
Assalamualaikum. My name Muhammad Zoriza bin Zulkifli, PC 18046. Okay, Akmal, can you explain to us how to calculate degree freedom, sum of square error, mean of square error, and F-test? And can you state the null and the alternative hypothesis to us? Thank you.
Okay, my name is Muhammad Akmal bin Muhammad Nazmi, PC 18098. So, for my part, I will explain about sum of square and degree of freedom and mean of square for treatment and error. So, and the lastly is for F-test. So, after that, I will state the null and alternatives hypothesis for this case study. Okay, let's go. So, we will continue for the table Anova. So before we get to the point, we will investigate about the table. So you guys need to know how to get this value. So as you can see, this one is SSTR. That's mean sum of square treatment, and this is SSE, which is this is sum of square error, and this one is SST, which means this is sum of square total. So how do you get this one? This one we can get it from SSE equal to SST minus by SSTR, then equals 75.3333 minus 389,333. So you will get SSE, which mean is 3C point. So how do we get this one? 2 is K minus 1, which mean K equal 3 minus 1. So we get 2. So how you get we will get this n minus 1. So all total the independent we get is 15. So 15 minus 1, so we get 14. And how do we get SSE for degree of freedom? So what we get is TR, this one, minus DR, degree of freedom, TR. So we get degree of freedom for E. Here, 12. After that, look at this. This mean the MS. This mean is mean square. So how do we get this? We can see in here. MSTR equal to which one? 38.933 divided by 2 degree of freedom. So we will get this one. This is sorry. So we will get this one. This is mean square for between group 19.967. So this one same like this. How do we get this? SSE equal to degree of freedom. So we will get 36.4 divided by 12. So we will get for mean square for within group is 3.0333. Okay, and lastly, how do you get the F-test? F-test is MSTR divided by MSE. So we will take this one, 19.4 6, 7 divided by within group for MS is 3.0333. So we will get this one, 6.4176. This is for F test calculation. Okay, look at the back. So the alpha is 0.05, and we can write here. So the alpha is 0.05 we use, then K equal to 3, which means mu 1, mu 2, and mu 3. So the first one is HO. HO is new hypothesis. So the new hypothesis is, so the null hypothesis HO is all population mean are equal or no treatment effect. There is no variation in means among group. Okay, and for the H1 is a alternative hypothesis. So there will be at least one pair of population mean different, or there are different between population means, or no all population means are equal, or no effect between treatment 1 and treatment 2 and treatment 2. Okay, that's all for the how to calculate DF, SS, SSE, MS, and F, and the null of hypothesis and alternative hypothesis. I want to ask Mr. Zul, can you tell us about test the hypothesis using the p-value and the conclude the hypothesis testing? Can you explain to us a little bit about that?
Okay, before we start, we must know that question 7 and 8 is using the p-value method. We must know that p-value method have a 4-step. First, determine the hypothesis. Second, determine the p-value based on the Microsoft Excel. Third, make a decision by comparing the p-value and alpha. 4, draw the conclusion. Okay, let I explain to you how to calculate. Question 7. Test the hypothesis using p-value. Step 1. Determine the hypothesis. After we read the study case, we can know the hypothesis. H-nail, all population mean are equal, and H1, at least one pair of population mean is a different. Step number 2 is determine the p-value based on the Microsoft Excel output. From Microsoft Excel, we can know p-value 0.0127. Let me show you how to find p-value using Microsoft Excel. To find p-value using Microsoft Excel, follow 10 steps. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Click OK. You will get the p-value. You also get degree freedom, sum, mean. Step 3. Make a decision by comparing the p-value and alpha. We can say, since p-value equals 0.0127 less than alpha 0.05, do not accept H-nil or reject H-nil. Question 8. Conclude the hypothesis testing. Question continue step number 4, which is draw a conclusion. At alpha 0.05, at least one pair of population mean is different, or there is difference in the population mean. That's all. Now we know how to calculate p-value method. Hopefully you guys know how to calculate the p-value method. Try to do some tutorial to give you more understand about this chapter 1 with Anova. Thank you for all the attention.